Pork and beef arrive at the receiving bays already chilled hard, because sausage quality starts with temperature control, not seasoning. Every combo bin and boxed load is scanned into traceability systems, sampled for microbial indicators, and checked for fat-to-lean ratio. Since the plant can't hit a consistent bite if the raw material drifts even a few % from the first minute, the factory treats meat like a precision ingredient with a narrow thermal window. If the fat warms and smears during grinding, you lose the clean particle definition that gives brats and smoked sausages their snap. So production rooms run cold and conveyors move fast? Large plants stage meat in tempering coolers to equalize temperature through the mass, because unevenly chilled meat loads grinders inconsistently and causes pressure spikes that change particle size. Trimming and pre-blending is where uniformity is engineered. Lean and fat are combined to a target formulation. It's often using automated scales and recipe software that meter exact weights into totes. Inline vision and metal detection protect downstream equipment, because one bone chip or metal fragment can damage grinder plates and contaminate thousands of pounds of product before it's caught. Grinding is not just making meat smaller, it's controlled particle geometry. High-capacity grinders use a feed screw to push meat toward a rotating knife and plate set, and the plate hole diameter sets the initial texture. Plants run multiple passes: coarse grind for structure, and a finer pass if the product requires it, while monitoring motor load and product temperature as real-time indicators of fat smear risk. Some lines use vacuum grinders to reduce entrained air, because oxygen accelerates oxidation and dulls flavor, and air pockets create weak spots during stuffing. The moment ground meat leaves the grinder, it goes straight into mixers designed to extract protein, distribute spices, and lock water into the matrix. Industrial paddle or ribbon mixers run under programmable timing and speed, and many operate under vacuum to tighten the batter and improve sliceability in smoked products. Salt is added early because it solubilizes myofibrillar proteins like myosin, which is the natural glue that binds fat and lean together. Without that extraction, the sausage can crumble, purge liquid in the package, and feel dry even when the formula is correct. Seasoning is treated like a controlled chemical addition, not a scoop and stir step. Spices arrive pre-screened, lot-coated, and often validated for low microbial load, then stored in humidity-controlled rooms to prevent caking and flavor loss. Automated batching systems dispense spices by weight into totes, with barcode verification to prevent recipe mix-ups, because one allergen error becomes an immediate recall risk. For smoked sausages and many brat styles, the mixer also receives cure ingredients, added with tight control, because cure is a food safety and color system as much as a flavor system. Water, ice, or chilled brine enters the mixer as a thermal and functional tool. Adding ice isn't about dilution. It absorbs heat generated by mixing and keeps the batter below the threshold where fat begins to smear. In high-throughput plants, temperature probes and batch logs flag any mix that creeps upward, because even a small rise changes viscosity and stuffing pressure downstream. Some sausage styles stay coarse by design, but others need a finer, more uniform emulsion. For those, the plant uses bowl choppers or inline emulsifiers that shear the meat through high-speed blades and screens, creating a stable fat and protein matrix. This is where engineering choices show up in the bite. More shear produces a smoother texture, while controlled shear preserves visible meat particles. The factory doesn't chase maximum smoothness. It targets the texture the brand is known for and tunes equipment settings to reproduce it every day. While mixing runs, casings are prepared in parallel because casing choice defines appearance, snap, and cook behavior. Natural hog casings bring a traditional bite but require desalting, flushing, and careful handling to prevent tears. Collagen casings deliver uniform diameter for high-speed linking and consistent cooking, which is critical when you're producing millions of links with tight weight specs. Stuffing is a pressure-controlled extrusion process. Vacuum stuffers pull the meat batter into a sealed chamber, evacuate air, and push it through a horn into the casing at a stable pressure. Removing air is not cosmetic. Trapped air expands during thermal processing, creating bubbles, wrinkles, and weak seams that split in the smokehouse. Servo-driven pumps keep fill rate synchronized with downstream linkers, so the casing tension stays constant. Because casing tension controls diameter, and therefore cook time, linking is timed mechanics. Twisting heads or clipping systems index the casing at precise intervals. Producing uniform links and weights at extremely high speed, inline checkweighers immediately sample output, and if weight drifts, the system adjusts portion length or stuffing rate to pull it back to target without stopping the line. That closed-loop control is how a factory maintains consistent packs while running continuous production. Asterisk. Fresh sausages and fully cooked smoked sausages diverge after linking. Fresh brats may go to packaging after a brief chilling and bloom period, while smoked and cooked products enter thermal processing where safety, color, and flavor are manufactured through controlled heat and humidity. Hanging systems load links onto smoke sticks or conveyors with consistent spacing, because airflow is the hidden variable in uniform cooking. Crowded product blocks smoke penetration and slows heat transfer. Industrial smokehouses are programmable climate chambers, not simple ovens. Fans drive high-velocity convection, steam injection controls humidity, and heating coils follow a multi-stage recipe that manages drying, smoking, cooking, and final lethality. Humidity control is critical because dry air toughens the casing and forces moisture out of the meat, reducing yield. Too much humidity prevents proper color development and can leave the surface tacky. The best systems balance humidity to build a uniform pellicle. It's a slightly tacky surface layer that helps smoke compounds adhere evenly. Smoke itself is engineered for repeatability. Some plants burn hardwood chips in controlled generators and filter the smoke to remove heavy particulates, while others use precisely metered liquid smoke atomization for consistent flavor with lower soot load. Either way, smokehouse sensors track time, temperature, airflow, and humidity, and the control system records the full curve for every lot as proof that the process met validated food safety requirements. Cooking targets are achieved by time and temperature. Lethality validated to regulatory standards, and plants verify it with calibrated probes and data loggers. If a chamber doesn't hit the required conditions, product is automatically held, not shipped. Because ready-to-eat sausage has no fix-it-later step for the consumer. This is why modern facilities invest heavily in automation and redundancy. A diverted batch is expensive, but a missed lethality step is unacceptable. When the thermal cycle ends, the process flips from cooking to rapid cooling. High-volume plants use cold showers, blast chilling, or spiral chillers to pull product through critical temperature zones quickly, protecting both safety and texture. Cooling rate also affects fat stability. If the product stays warm too long, fat can migrate and create greasy pockets that show up as purge in the package. For many smoked sausages, peeling is next, especially if a non-edible cellulose casing was used. Mechanical peelers slit and strip casings at speed while preserving surface integrity. Then product passes through washers or steam tunnels that remove surface residues. The peeled links are immediately re-chilled to keep them firm for packaging and to limit surface moisture that could weaken seals. Packaging is where shelf life is built, and it's as much gas management as it is plastic film. Vacuum packaging removes oxygen to slow oxidation and microbial growth, while modified atmosphere packaging replaces air with controlled gas blends that protect color and reduce spoilage. Thermoformers pull trays from roll stock, load product with robotic pick-and-place systems to prevent deformation, and heat seal lidding film under controlled pressure and temperature to produce consistent seals at high speed. Asterisk. Every package is inspected in-line because high throughput leaves no room for spot checks only. Checkweighers reject underweight packs to meet labeling rules and overweight packs to control cost. Metal detectors and X-ray systems scan finished product, and they're tested repeatedly during the shift with standardized test pieces to prove detection capability. Vision systems verify date codes and label correctness, because a correct product with the wrong label is still a compliance failure. Case packing and palletizing are optimized for speed and cold chain stability. Automated case packers collate packages into cartons with consistent orientation. And robotic palletizers build stable loads designed for airflow in refrigerated trailers. Stretch wrappers apply controlled film tension so pallets don't shift without crushing the product. And temperature data can be tracked through distribution to confirm the cold chain stayed intact. Behind the visible production line is a plant-wide system focused on uptime, sanitation, and yield. Clean-in-place circuits, wash mixers, stuffers, pipes, and brine lines with programmed caustic and sanitizer cycles. Using conductivity sensors to confirm chemical strength and flow sensors to confirm proper turbulence for soil removal. Open equipment like conveyors and linkers is cleaned with foaming systems. Then verified with ATP swabs and microbiological sampling to ensure the plant starts the next. Run with a controlled baseline. Allergen control and recipe segregation are engineered into scheduling and air handling. If a specialty sausage includes dairy, mustard, or other allergens, the plant runs it in defined windows with validated cleaning between products. And labeling systems lock the correct film and cartons to the correct batch. That control prevents cross-contact while keeping the line running efficiently. Yield is tracked continuously because sausage is a business of small margins multiplied by enormous volume. Plants monitor trim loss, grinder recovery, moisture addition, smokehouse shrink, and packaging purge. Then adjust mixing temperature, humidity profiles, and handling to protect final weight without compromising texture. Even smokehouse airflow patterns are optimized because uneven airflow causes uneven shrink, and uneven shrink creates inconsistent package weights. Downstream, the million sausage scale is possible because the process is modular and data-driven. Raw material intake is stabilized by standardization and temperature control. Texture is stabilized by controlled particle size and protein extraction. Safety is stabilized by validated thermal cycles and rapid cooling. And shelf life is stabilized by oxygen management and seal integrity. What looks like a simple brat on a grill is the output of sensors, servo drives, vacuum systems, thermal engineering, and continuous verification built to deliver the same snap, the same juiciness, and the same flavor profile, link after link at industrial speed.